Okay, again, we're looking at given set of coordinates, inputs that give you outputs, and the first thing you want to consider, if our rate of change of our inputs, what is going to be the result of our outputs? So first thing we want to do is we want to look at slope. Slope, which is also known as our m in any sort of point slope or slope intercept. Our formula to find slope, or rate of change in y over change of x, is y2 minus y1, x2 minus x1. Okay? We just like to look at our coordinates. Basically, if this is the first set of coordinates you see, let's call this x1, y1. And then you would, if you put this as your x1, y1, and this is your, you would get the same result. Okay, but I like to just give yourself a pattern, give yourself an order here. 5 minus a minus 4 over 0 minus a minus 2. Let's make this a minus 5 actually in this case. I want to make that a minus 5. I want to look at a negative slope. So here again we talked about when you're putting in a negative coordinate, let's say a y1, you have to look at the fact that your formula, slope formula, already has a negative. So you're putting in a negative value. You're going to have a negative result. Same thing with putting in our x1. That is a negative. You're doing minus whatever your x1 is. In this case, a negative 2, so you end up with 2 negatives. Okay? Now we have negative 5 plus 4. The difference is 1. Obviously, you have more negatives than positives. 0 plus 2, 2. Here we have a negative slope for our m when we start working with our slope intercept. Okay? Now, what we want to do is get ourselves to slope-intercept form. So what we want to start with is our point-slope form. Y minus y1 is equal to m, x minus x1. Okay? Remember, either coordinate you choose will give you the same slope-intercept. Let's take a look at the one with the negatives. Good one to look at because when you're plugging in your y1, okay, you're going to again end up with that negative situation because you're doing minus a minus number. And then our slope, negative 1 over 2, x minus whatever x1 is. Again, you're subtracting a negative value. So don't forget, and don't just make this x minus 2. This is an x minus a minus 2. Our signs change. And you end up with y plus 4 is equal to negative 1/2 x plus 2. Now again, you're distributing, so you have to focus on the fact that you're multiplying a fraction to a whole number. So you're doing 1/2 times a 2 over 1, which gives you a negative 2 over 2, or we can reduce this to a negative 1 here. All right, so let's take a look at that. Y plus 4 is equal to negative 1/2 x. I distributed my negative 1/2 to my x, and a negative 1. Subtract 4, subtract 4, y is equal to negative 1/2 x minus 5. If I try my 0 and negative 5, I would get the same result. Y minus a minus 5 is equal to negative 1/2 x minus 0. I get y plus 5 is equal to negative 1/2 x. Subtract 5, y is equal to negative 1/2 x minus 5. We have a match. Now this slope-intercept gives me 2 pieces of information, important information here. It gives me a slope and a y-intercept. We represent that with an m, our slope, negative 1/2, and a y-intercept, negative 5. This is our starting point. This is what our y or output would be if we put in 0 for x. Negative 1/2 times 0. That's your understanding there. If I have 0 input, I'm not putting in any number for x, what would my y value be? And that helps us graph. Because 1, we start at 1, 2, 3, 4, 5, our -5. And our slope a little different this time around. Last time it was positive, we went up. Now because it's negative, we go down. And what we're usually doing is we're just applying the positive or negative sign to the top number. We're going to start by going up or down, and then always over, considering that the bottom number here is positive, we're going over. So here we have down 1, over 2. Down 1, we've gone down, -1, and then over our 2. And we can make our graph here. Okay. Let's look at some values if we're trying to solve for, let's say and we'll just go over 1 unit for x. When x is -3, I could plug in and say, okay, y is equal to -1/2, 3 plus 5. Y is equal to, here we have, let's say a fraction here, -3/2 plus 5. That's a good thing to look at. Really, this is like a -1.5 plus 5, which give me a difference of 3.5. So we could say when our x is 3, here, our y will be about, actually this is a -5 here. So we're actually going to have a total of -6.5. And see how I made that mistake? And I saw 3.5 there? And I look over here, I was like, wait, that doesn't make sense. Here I have a -5. Here, if I'm going down or over 1 unit, it looks like I'm only going, a certain amount. It looks like I'm only going to like a 6.5 here. And then let's say they want to solve for or a certain output. Okay, let's look at when. Let's see, we would go up 1, back 2. Let's look at it when x is -2. I'm sorry, when up 1, back 2 would make y. What's y? What is x when y is -4? -4 is equal to -1/2 x minus 5. Let's add the 5 to both sides. And then we get 1 is equal to -1/2 x. Multiply both sides by -2/1. I would get x is equal to -2. And again, it makes sense, because if I look here where x is -2, it does give me a value of y being -4. And that's where the graph helps you. It helps you look at and make sure that when you put in a certain input and ask for an output, or you put a certain output and you're asking for an input, this graph is gonna allow you to check some of your answers there. You can kill it in there. And this is what your